Welcome back. In this module, we are diving into Object-Oriented Programming, or OOP. It's a fundamental concept in C# and many other programming languages. It's a key approach for structuring and organizing code effectively. By end of this module, you will have a solid understanding of OOP principle and how to apply them in C#. Let's start by understanding what's basically OOP. It's a programming style that organize code around object and class. Object gonna represent a real-world entity with attribute and behavior definitely, while on the other side, a class is just a blueprint for creating objects. In C#, we're gonna use OOP to structure our program in just a way that both logical and reusable. Let's imagine together we're gonna design a program that manages cars. A car would be an object with attributes like color and speed. On the other side, we can say behavior like starting the engine or stopping the engine. So OOP let us create these models in our code, making it easier to work with complex system. So let's go over the four main principles of OOP, which are gonna be encapsulation, abstraction, inheritance, and polymorphism. I would like to start with encapsulation, which is gonna be our first topic here. Encapsulation is about bundling data and method that work on that data within a single unit, typically in our case gonna be class, and restricting access to some of the class component. This is gonna protect sensitive data from unauthorized modification. Next here is abstraction, which is gonna involve hiding complex details and showing only the necessary feature of an object. Think of it as a way to focus on the essential while ignoring the complexity behind the scene. Imagine you have a coffee machine. All you need to press on a button to get your coffee. You don't need to know how it heats water or grind the coffee beans or any kind of unnecessary details. And then let's move to inheritance, which is basically the concept of reusability in software engineer that gonna allow a class to inherit properties and methods from another class. And it's very important in software engineer, which is gonna enable us to create a hierarchy of classes that share a common behavior. Let's say we have a vehicle as a parent class and we wanted to create two children classes like car, truck, which are gonna inherit some methods like start and stopping engine from the parent class. Then let's move to the latest here, which we call it polymorphism. Polymorphism, which is gonna mean many shapes. It's basically very important for flexibility and extensible code. Imagine we have a shape as a base class and we have circle and rectangle. Each of them gonna implement one method, call it draw. But with circle it will have a different equation for drawing than over rectangle. But by end of day both of them have the same name. So let's explore again what's basically classes and objects. We can say a class, it's a blueprint for creating object. An object is just an instance from that class which is gonna have two types. The first one we call it data, or sometimes we call it fields, and on the other hand we call it methods or behavior. Then let's move to the constructor, which is just nothing, it's just like a special method in a class that get called automatically when an object is created. And last, let's have a look about access modifier, which is gonna control the visibility of a class member. The most common are public, private, protected, and internal.